Go.
That wasn't the 5-minute rule, right? No, that was, all right, start again. Okay, here we are back, right? We're back. All right, part 2. We are applying our rules, and the number of tanks in the box was 186. So who came the closest?
Oh my gosh, you got the maximum.
186.
Lena did.
No, I did.
Oh yeah, I did get the max in, and then look at me.
That's so
Oh wait,
crazy.
yeah, you did.
Is 306 the closest?
No.
What? No.
Mine is the furthest.
Mine is
Yeah.
the closest.
Caleb's is.
Mine is the closest.
It is?
Wait,
All
let's
right,
see.
229.
Math.
All right, good job.
What did you do?
I did the outlier
You're
rule.
43 off.
All right, so what we're going to do in this chapter, this
You know what that
probably,
is?
ask you, why are we doing
Okay.
this?
You're supposed to.
We're going to actually taking
What's
samples
the problem?
and inferring things from them, just like you tried to do with your statistical rule. At the end of the
I just
chapter,
got
I will
lucky.
tell
I
you
haven't-
what the rule was that the government used and how successful they were. All right, so let's go ahead and write that in words. Do you see where it says Chapter 7 goal? What inference can be made from sample data to describe the entire population? That's just what we were trying to do. We were trying to infer something from a sample and to describe an entire population when I don't have an entire population. I only captured 8 tanks. The whole
You don't know if they
campaign.
were random. They could have been. It's like you don't.
They could have been
If it's
purposely
not,
put there.
if it's not random sample, then you can't make the inferences. I
Yeah,
mean,
well, the inferences are definitely going to be weakened. You're right. So, but we got, that's real life. This is a real life statistical problem, and believe it or not, our government got extremely close to the number of tanks there actually were. And I'll explain that a little later. All right, did you fill in those blanks? The first vocab word is parameter, P-A-R-A, parameter, parameter.
Bah.
A parameter is a number describing a characteristic of an entire population. And it's often unknown, and my
Population.
parentheses fell off the face of the earth there, so you can put in another parentheses for me.
I'll be here all week, and by
It's
all
the
week I
least
mean
you can
the
do.
rest of today.
I'll be here for 4 hours.
All right,
What did you want to say?
stop chatting, we just have a few minutes. Statistic. A statistic is a number that describes the characteristic of a sample. This is a good memory aid. You're good at making memory aids. How can we remember parameter goes to population and sample goes to statistic?
Oh gosh, what could it be?
I don't know.
There's
All
nothing
right,
that's similar
well,
about
You
them.
can work on that, it's gonna be tough. Circle the S's, circle the P's, and you will remember that forever. You will know it on your deathbed. I will crawl up to
Because
you.
if he doesn't go to the S, and the
I'll
S
ask you
doesn't go
at the pearly gates, I'll ask you.
She said on her deathbed she'll crawl up to us and ask us.
You know how people say
There won't
that,
be
like,
even any
falls,
crawl
like,
left in
when
me
you're
by
on the
your
gates of
deathbed.
heaven,
Hopefully.
she's gonna be
Hopefully
just
you
gonna ask us
outlive
what
me
it
by a
is.
long time.
We're not gonna
No,
see the
we want
angels,
you
we're
to
gonna
live
see
as long as we
the
do. You want to be there with us all the time.
Alright. A statistic, and see if you can figure out what I'm going to say. A statistic can help estimate a parameter. You guys read ahead.
Wow.
You were really bored. Alright, we've seen these symbols before. Let's just remind ourselves that the mu is the mean of the whole population.
Mu equals me, the whole population.
So that's when
Stochastic.
you know every individual, and you have data on every individual, you have the mean. But we usually don't have that, so we settle for X bar, which is the mean of a sample. Then we have a new player that's come out to play with us, and that's P is for proportion. So a proportion of a whole population, like suppose we knew data on every American citizen, adult citizen, 18 and older, the proportion of people who smoke. What do you think P might be? 0.25 maybe? 0.12? I don't know how many smoke. Still a lot of people.
3,
Yeah, 0.15.
2.
All right, so
15%
P
of
for the
people?
whole population
0.35.
is when we put a hat on and we read it P hat, it's the
0.45.
proportion.
I don't know.
No, definitely not.
The
Why do people smoke?
proportion from a sample is
it's like
P hat.
10%.
I think it's more now.
So
I think it's less.
Less than 10%?
Yeah.
smokers.
Yeah.
Yeah.
What
I
is
don't
it?
think so.
You're a stat
Wouldn't it
teacher,
be
you
like
should know all of
10%?
them.
I'll look it up, but not right this second.
I'm pretty sure it's more than 10%.
I'm pretty sure it is.
All right.
I think
Are we
it's like
talking about smoking tobacco?
smoke,
Well, it's
smoking.
just smoking. I guess that would be anything like
Smoking.
pipes and cigarettes and cigars and
Then I would.
Marijuana? Like, just like normal, like, just,
yeah.
Are we
are we just talking about
marijuana.
tobacco?
I don't know.
Because
Let's
usually when we talk about
let's say
smokers, we're talking about like just tobacco.
cigarettes. Yeah.
Yeah.
That's what I had in
Well,
mind.
Okay, then I would say.
Allie, would you read the little problem there?
Okay. Problem. Identify the population, the parameter, the sample, and the statistic in each of the following
I only
settings.
gave us one to practice, and then you'll have, this is why I said your homework will be quick, because there's like 5 of those kind. So read the first, what is the first example, Allie?
We didn't write down
Okay. The Gallup poll
Yep.
asked a random sample of 515 U.S. adults whether or not they believe in ghosts. Of the respondents, 160 said yes.
All right, take a moment and see if you can identify for yourselves in writing along the side there, what's the population, what's the sample, what's the parameter, and what's the statistic? Looking up and reminding yourself what all those stand for. You still have those numbers. I don't think I'll get to use them later, but just in case.
I got the min and the max, did you know?
I know, they're kind of like wrecked a lot of the statistics though.
I'm sorry.
I think those are mine and Caleb's that are left. Oh wait, here's another one.
Alright, is there any
Oh
more?
wait, I just found another
You
one.
didn't do your thing yet.
I was writing
I
this.
can't be missing one.
No, I was
Or
writing
we'll
Yeah, but I'm
be,
saying now we're doing this.
I don't.
You should do it.
a
I
random
don't know. I don't
sample.
know what's on.
Alright, did you say that the population
Yes.
was all US adults?
Yes.
Yay! Did you say the sample was the random 515 adults?
Yes.
Did you say the parameter, I guess I could just say it's the proportion of all the adults who believe in ghosts. They didn't give us a number.
I
So
just
you're
said
gonna,
unknown.
so if you would write in words, it's the proportion of adults who believe in ghosts. So when the parameter isn't listed as a number, it definitely is unknown. Then your job is to write it in words. And the statistic is 160 out of 515. That's P hat, and it's 0.31 if you actually calculated it. All right. Any questions about what those words mean? You'll be doing that tonight in your assignment. X bar on the back. X bar is calculated from a random sample. So X bar, remember, was the mean of a sample. So I've collected a random sample from some population, and I have calculated the mean once I drew those out. If I took another random sample, like for example the tanks, if we had figured out what the mean was of those 8 draws, what if I threw those tanks back in and had you draw 8 more and find the mean? Would they be the same mean? Probably not. There's a possibility that it could be all the same numbers drawn, but it isn't likely. So, if X bar is calculated from a random sample, and if I took another random sample, X bar would probably be different. And this is what we're actually studying in this whole chapter. This variation in X bar is called sampling variability. Variability. So, sampling variability. Are you missing any blanks?
Not yet.
All right. The variation in X bar is called sampling variability. So I'm not just talking about X bar either. I'm talking about all of these statistics. So in more general terms, would you fill in this blank? In general, the value of a statistic varies in repeated random samples. In general, the value of a statistic, remember any of these things, max, min, Q1, Q3, the value of a statistic varies in repeated random samples. I didn't think we would have time today. I was going to have you actually take the samples. I was going to change the I was 186 tanks in here, but I have numbers up through 200. So I was going to throw them into the hat there and have you draw 20, but it's going to take too long, each of you. So it would take too long for you to draw 20, put them back, and you to draw 20, put them back, and so forth. Where it was going to assimilate 200 chips and 200 like poker chips.
I can do that.
So 100 are red. Anyone have poker chips?
With us?
No, that is
Oh,
100 are black.
because
I
I
didn't
have
have
some
that
with
many
me right now.
poker chips, so I made these. I figured if we had 1 to 200 in here, if I drew from 1 to 100, it'd be red, and 101 to 200 would be black. But we're not gonna. So I actually drew a couple myself.
What?
So I selected 20, and then I had this little graph.
Yeah.
And I already put it on there for you. Oh no, is that 5 minutes?
No, that's the
Okay.
end of the thing.
All right.